Also, we'll have more examples of graphing functions using its first and second derivative tests. For the first example, our first line is our critical points, which are 0, 2, and 4. Next, we construct the table of signs for the first derivative test, and that is positive when x is less than 0, as well as when x is greater than 2 but less than 4, and it's negative when x is greater than 0 but less than 2, or x is greater than 4. This means that at these two intervals, the function is increasing, and at these two intervals where f prime is negative, the function is decreasing. For the second derivative test, we have a positive f double prime x. If x is greater than 1 but less than 3, that means it's concave up. And we have a negative f double prime of x. If x is less than 1 or x is greater than 3, that means it's concave down at these intervals. Let's plot some arbitrary points that are critical points and points of inflection. We'll graph our first interval at x less than 1, and here we know that it's concave down and has a local maximum at x equals 0. Our next interval is the interval in between 1 and 3, where it shifts concavity and it becomes concave up and has a local minimum at x equals 2. For the last interval, that is x greater than 3, we know that it's concave down and it has a local maximum at x equals 4. When you combine all these information, your graph would look something like this, and we're done. For our next example, let's construct the f double prime x table of signs, and that is positive on these two intervals and negative on this interval. Our information for the first derivative test is that it's positive for all x except x is equal to 1. This is because at x equals 1, it has a vertical asymptote. The concavity of the function is it's concave up before x is equal to 1, concave down in between 1 and 3, and concave up again beyond 3. So that would look something like this. Taking note that as we go from left to right, our function must be increasing because our first derivative test is positive for all x values except 1. And we're done. Thank you for watching. See you on the next video. Bye!